There's toxic gas flowing out of Enceladus that could be the key to life. Could there be black holes inside stars? And NASA tight beams a cat video from space. All this and more in this week's Space Bites. Enceladus is one of the most exciting places for us to study here in the solar system. And we know that there is a liquid ocean of salty water underneath a thick shell of ice. And that water is making its way to the surface and being spewed out into space from these geysers at the south pole of Enceladus. And thanks to observations from NASA's Cassini spacecraft, we know that there is hydrogen gas dissolved into this water. We know that there are various organic molecules, like everything that life might need seems to be contained in this under ice ocean. And now researchers have found one other thing in Cassini data, and that is hydrogen cyanide. Now, hydrogen cyanide, like that sounds unhealthy, and it is poisonous in large amounts, but these are trace amounts found inside these plumes that are coming out of Enceladus. And hydrogen cyanide is really exciting because scientists think that it is an important precursor to life on Earth, that hydrogen cyanide has a role to play in the formation of amino acids and nucleic acids, and could be, again, another reason why Enceladus is a fascinating place to study. We've really got to go back to Enceladus. New Webb images of Uranus. All right, we got an update from Webb, and this is another set of images of Uranus. And we actually had images from Uranus a year ago, and now we've got a new set. And this new image, like clearly the astronomers have learned some lessons from last time, and this image is just stunning. You can see straight down the north pole of Uranus. And of course, that's because the planet is tilted over onto its side. It's like it's rolling around in the solar system on its side. And so you can see this delicate ring structure. And the part that was really quite exciting was that they could see the innermost ring, this very faint one called the Z ring. Taking images of Uranus is actually quite difficult because the planet has a 13-hour rotation, which means that it's moving very quickly from the perspective of Webb. And so astronomers weren't sure that they were going to be able to even get these images of the storms and cloud patterns and other features around the planet. You can also see a bunch of moons in this image, but these aren't actually Uranus's big bright moons. They're farther away outside of the image. You've just got a collection of smaller moons closer to the planet. NASA streams a cat video from space. I think one of the big things that people don't understand about space exploration is how much bandwidth is a problem. When you think about NASA's New Horizons mission, when it went to Pluto, it took all of its images just over a couple of days, gathering images of Pluto and its moon Charon at various resolutions. It saw different hemispheres, it was able to do other data. It then took 18 months to send all of that data back home very slowly. In some cases, it was just sending it in bits per second. And so when you think of the requirements of future spacecraft to be gathering enormous amounts of data, the farther away you get from Earth, the slower it is to send your data back when you're doing this in the traditional method. When you've got this radio transmitter, you've got this gigantic dish on Earth that's receiving the transmission. And so NASA is testing out a new technology. Can you send information with lasers? Now, when you think about like science fiction, when you think about The Expanse, there is this term they use. They call it send a tight beam. In other words, they're saying send a laser directly at a target that contains the maximum amount of information that nobody else can intercept the signal. And so NASA sent a tight beam from the Psyche spacecraft when it was at a distance of 31 million kilometers away. And this is the point where you're going to start to see a degradation of the signal. You're going to need a higher power transmitter, or you're just going to have to get lower bandwidth from the spacecraft to the receiving station. They sent a laser pulse in near infrared, and it was received by a telescope near San Diego. So here's the part that's crazy. They were able to send a 15-second video at 267 megabits per second. Like, that is broadband speed. That is closing in on fiber speed. The signal took 101 seconds to go from the Psyche spacecraft to Earth. And Psyche doesn't even have a way to record high definition video. So instead, they preloaded this cat video onto the spacecraft, and then at the right time, it sent the cat video back home at blazing fast speed. I mean, I really think this is a game changer. Like, if they're able to master this technology, then you're going to be able to see spacecraft around the solar system tight beam with lasers their data back home in a way that just a telescope can receive it, and then they're able to decode it. And so you could get all of that data from, say, the New Horizons mission in just a few hours, as opposed to waiting for months and months for it to happen. And so I think this is going to be one of the biggest stories of the year. And hopefully over the coming years, we're going to see this technology play out again and again. So I'm really glad they did this test on the Psyche mission. Could there be black holes inside stars? Now imagine if a black hole fell into the sun. It would be a big problem. And that's because, like, a black hole is going to have many times the mass of the sun packed into an area that is relatively small, and it would gobble up the sun from inside. I mean, it would be the most gravitationally dominant thing inside the solar system. But there is this idea of primordial black holes that were formed in the earliest moments after the Big Bang. And these could be any mass, from the mass of an asteroid to the mass of a planet to thousands of times the mass of the sun, and they could be drifting around the universe. And in fact, that could be one explanation for dark matter. And so one idea to search for these primordial black holes is to find the ones that fell into stars. Now, for the most massive black holes, if they fell into stars, they would consume them from within. And so these black holes, after consuming a star, would still be less massive than the size of the smallest possible black hole that could have formed from, say, a supernova. And so if astronomers find a black hole with only, say, a couple of times the mass of the sun, there's no way that could have formed unless it was a primordial black hole that ate a star or two. But even smaller black holes could have an effect on their star. They wouldn't be able to completely consume the star from within, but instead they would be locked down inside the core and would be churning up the core of the star. And that would change the amount of heat that the star is outputting. It would change its size and the color spectrum that's coming off of that star. And so astronomers have thought that you could search for stars that are a little bit cooler and a little bit larger than what you would expect from a star of that age and size. And that might be an indication that there is a black hole inside the star that is consuming it from within. And then that might give us the evidence that there are primordial black holes. And there's definitely not one inside the sun. Like, we would see through astroseismology, we would see ripples on the surface of the sun that would tell us that there's a black hole inside. Every week, we do a vote on our channel where you get to tell us what you thought was the biggest space story of the week. And the winner last week was Voyager 1 is down. And like, obviously you're not excited about that, but it is a very important story. And unfortunately, I have no update for you yet. So you will see this vote show up on our channel. We put it into the community tab, but also if you're just scrolling on your phone, you should see the vote come through in a couple of days. Tell us what you thought was the best story, and then we'll tabulate them up and we will talk about them here. Of course, the best chance to get that is to subscribe to the channel and click on the notification bell. Could photonic crystals help break through Starshot? We've talked a lot about breakthrough Starshot. This is this idea that you send teeny tiny light sail spacecraft to Alpha Centauri, Proxima Centauri. You fire a powerful laser, the light sail reflects the laser, accelerates to say 10% the speed of light, and it's able to make the journey from here to Alpha Centauri within a human lifetime. That would be nice. But there is a laundry list of to-do items which are beyond our understanding today. Like, how do you make a laser that powerful enough? Where do you put it? What kind of material would you use to reflect the laser that would allow the spacecraft to accelerate under enormous G-forces and not just vaporize? So researchers found a new interesting material called nano-manufactured photonics crystals. And this might just be what Breakthrough Starshot is looking for. This technology is actually kind of similar to the reflection that you see from animal eyes at night. When you see a cat's eyes or dog eyes or deer eyes shining in the night, it's similar to these photonic crystals. They reflect very specific wavelengths of light in the 1300 nanometer to 1500 nanometer range. And so you could fire a high power laser in exactly that wavelength. You're going to get a very high reflectivity off of the photonic crystals, and you should get that acceleration. So one item of the gigantic laundry list of to-do items might have a possible solution. What I'm saying is that don't anticipate Breakthrough Starshot leaving anytime soon. Betelgeuse versus an asteroid. Now, a few months ago, we learned that Betelgeuse was going to pass directly behind an asteroid. And this is known as an occultation. Like a fancy version of this is when the sun passes behind the moon. That is an occultation. And we see that here on Earth as a solar eclipse. And so if you're in exactly the right path on Earth when this asteroid passes in front of Betelgeuse, then you're seeing an eclipse of Betelgeuse from an asteroid. And so these occultations happen all the time. There's places you can go to look up all the upcoming occultations, and they're very valuable scientifically for two reasons. One, they tell you about the object that is doing the occulting. In other words, the asteroid, the Kuiper Belt object, whatever it is that is passing in front. This is how people find rings or moons around asteroids. But you also learn a lot about the object that is being occulted. You can detect the outer atmosphere of the world, or you can detect the size of the star. So astronomers tracked the asteroid 319 Leona, and they waited until this precise moment when it was going to pass directly in front of Betelgeuse. And then they tracked the changes in brightness of Betelgeuse. And they were surprised to find that it didn't change very much, that it wasn't this clear, like Betelgeuse switched off and then it turned back on again when the asteroid had passed. Instead, it did change a little bit in brightness. And it's believed that this is because we're learning that actually Betelgeuse is probably a little bigger than astronomers had originally thought. And the shape of the asteroid is probably more oblong than spherical, and so you didn't get this perfect matchup. And so you didn't get this perfect eclipse. You got an annular asteroid occultation. And so there's an enormous amount to learn. So all of the amateur astronomers, all the professional astronomers who watch this occultation will be able to pass along their information to the scientists, and they'll be able to then better map out the shape of Betelgeuse and better map out the shape of 319 Leona. All right, I want to take a second to thank everybody who supports us on Patreon. And to be honest, we couldn't have done 2023 in the way that we did without your help. Advertising revenue is in a steep decline. The search engines are kind of no longer sending traffic to websites at the level that they used to, because now, like when you go to Google and you search for something, it just gives you the answers. There's no need to do any more research. And so we've been able to make up that shortfall in our income thanks to Patreon. At this point now, I feel like we're in striking distance of being able to just be fully Patreon. Imagine if we had just an independent space news agency that was supported by the patrons. There's no need for advertising. That would be amazing. And so we're not there yet, but I'm hoping that we'll be able to make that transition maybe in 2024, maybe 2025, and we could really use your help. So if you want to support the work that we do, if you want to help me pay the salaries of the writers and the video editors and the programmers, everybody who works for Universe Today, go to patreon.com/Universe Today. And of course, if you sign up, you get ad-free version of Universe Today, you get advanced access to things, you get our patron-only audio stream, but mostly you know that you're helping us switch over to being completely patron-driven, and that will be amazing. So thank you. Yeah, people don't even realize, like, I would have had to have laid off a bunch of people if we didn't have Patreon. That would have sucked. Blue Origin is back. All right, this week we got another test of the New Shepard from Blue Origin. And it was the standard test. The thing took off, flew to an altitude of about 100 kilometers, detached the top section, it landed with parachutes, it had dozens of scientific experiments on board, and the point was that they were able to show that they could return to flight. This is the first time they've flown since September 2022. There was a flight anomaly, and so they've been taking some time to do some testing, but like no paying passengers have been on these suborbital flights. They haven't been able to do their science experiments. But the bigger thing is, like, when is New Glenn going to fly? Like, partly they're learning lessons from New Shepard, which they can then apply to their big launch rocket. And it was originally supposed to launch in 2020, and now here we are, still hasn't flown. The rumor is that they're going to try their test flight in 2024, probably August. And that's really important because in 2024, there is a window to be able to launch a mission to Mars. And there is a NASA mission that's going to be launching on a New Glenn, and they would really like to hit their launch window, please. So there is some incentive for Blue Origin to get their New Glenn flight sometime next year. Another static fire for Starship. It's been a month since we saw the dramatic integrated flight test 2 of Starship and Super Heavy. This is where they tested both the Super Heavy booster and Starship together, and progress has been continuing. And so this week we saw a static fire test of Starship 28. And then they also rolled out Booster 10. So the thinking is they're going to stack up Ship 28 on top of Booster 10. And this is going to be the next integrated flight test that's going to come probably in the next month or so. Although we haven't gotten any kind of official explanation of what happened last time, nor have we got any sort of official planned launch date. But obviously, with SpaceX, we sometimes only get a couple of weeks notice, days notice before we get the next flight test. This time, the hope is that the thing will launch, that the parts will separate, they will both soft land to their various locations in the ocean, and we will have like the preparation for the next test, which is to go fully into orbit. All right, we've got a couple of cool images and videos to show you. First, I want to show you this 14-year time lapse from NASA's Fermi Gamma Ray Observatory. And this is a spacecraft that is taking all sky images from space of gamma radiation. And the largest source, of course, is the Milky Way, which is passing through the center of this image. And then if you watch, you can see this object move through on a regular basis, and that's the sun, which is giving off some gamma radiation, but not very much. And then you've got these various bright objects that are off the Milky Way, and those are blazars, which are actively feeding supermassive black holes that are throwing out gamma radiation in our direction. And then every now and then you get these flashes, and those are gamma ray bursts. I highly recommend you click through and watch the full video from NASA, because the principal investigator from the mission sort of talks about what you're seeing in the images and explains it. And I found it really fascinating. So check that out. And finally, we've got a Christmas tree in space, and this is actually called the Christmas Tree Nebula. It's been colored green to, I guess, make it look more like a Christmas tree. And then what's cool about this is that it's been overlaid with images from the Chandra X-ray Observatory, which of course is seeing bright X-ray sources within the Christmas Tree Nebula. It's a young nebula, and what that means is that you've still got young hot stars that are very bright in X-rays. And so they turned that layer on and off, and it kind of looks like lights blinking on a Christmas tree. So enjoy. Happy holidays. I'm going to talk more about bandwidth in a second, but first I'd like to thank our patrons. Thanks to Hey Twyla, Dougie Stewart, Steven Krasaki, David Richards, Mark Anstis, Joel Yancey, Antonio Lofilara, Dustin Cable, Vlad Shiplin, Modso, George, David Gilton, Andrew Gross, Jeremy Mattern, Josh Schultz, Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I'm sure you noticed I'm pretty excited about this high-speed test of sending a cat video from the Psyche mission. And that is because, as I said, this is kind of a game changer, that maybe we have a brand new way to be able to send data back from spacecraft to Earth. And right now there is the Deep Space Network, which are these gigantic radio dishes that are around the Earth that are able to keep track of various spacecraft. And you can actually go to the Deep Space Network's website and you can see which spacecraft, which telescopes are talking to at any one time. And it is oversubscribed. Like, there is too much communication to send to and from these different spacecraft. And part of that is because, think about it, like when you're trying to receive all of that data from New Horizons, and you're gonna have to keep watching the spacecraft for 18 months as it just sends you dribs and drabs of data over long periods of time, it's very resource intensive. And so if we could switch to this world where all of the spacecraft have laser transmitters, they're able to either send back to Earth, or maybe they're able to send messages to each other to consolidate information into larger packages and have a bigger transmitter to be able to send that back to Earth. Like, we're moving into this entirely new paradigm of how we send data back to Earth. And a lot of the coolest ideas for space telescopes, for, like, imagine the Event Horizon telescope, but the size of the solar system. It's not that you can't put the spacecraft out there, it's that we don't have a great way to get that data home. And so spacecraft that have been canceled or have been pushed away because they don't have a good way to get that data home now suddenly are possible again. And so I think over the coming years, as this technology gets implemented and more missions, we're going to see a revolution in the kinds of spacecraft. We're finally going to see that just live stream webcam coming from Mars, which I know everyone keeps asking me about. This is it. This is how we get that. All right, we'll see you next week.